Hello, my name is Kimberly Ying, and I'm a PhD student at the University of Florida, advised by Dr. Christy Boyer. Mahona Ahmed is an undergraduate student at the University of Florida who I've worked closely with for the last couple years. Mahona led the study and the development of the prototype. We originally planned to co-present this work at the SIGCSE 2020 conference in Portland, Oregon, but due to the coronavirus pandemic and subsequent conference cancellation, I will be remotely presenting this work on behalf of our entire team. This talk is on our SIGCSE 2020 paper called On the Design of a Mobile Java Practice App, a Comparison of Question Formats. Providing meaningful practice opportunities to engage students can strengthen their grasp of the computer science knowledge. While there are existing tools such as coding environments, virtual tutors, serious games, in-class assessment tools, feedback tools, and web applications, we see an opportunity to utilize mobile platforms as well. So why mobile? Because smartphone access is ubiquitous. According to the Pew Research Center, 95% of teens reported having access to a smartphone, and smartphone ownership is not significantly different across gender, race, ethnicity, or socioeconomic background. This is in contrast to computer access, which varies by household income and parents' level of education. Additionally, a survey of American college students found that 73% reported using their phones often to get information, and 77% reported using them when they're bored. For these reasons, we believe mobile applications can provide opportunities for students to practice which fit their lifestyle. So, how should we leverage mobile phones for coding practice? Traditionally, students write out code to learn programming using some kind of text editor or IDE, as you see here. Doing the same on a mobile device doesn't seem practical. So what else can we do? Previous research has shown that tracing code is another method students can use to learn, and that it is common for beginners to trace code before writing out code. With that in mind, we set out to develop an app that provides meaningful Java practice via tracing code. To inform the design of the prototype, we ran a series of user studies. These studies followed a user-centered approach in order to better target the needs of the user. Specifically, we used think aloud sessions, focus groups, and A/B testing. To guide the rest of this talk, we will be following this outline. First, we will discuss overviews of the studies used in our user-centered approach. Afterwards, we will discuss the details and findings of these user studies. Then we will go over the discussion, conclusion, and future work. To begin, we will be describing the general scope of a focus group. Focus group sessions can aid in the understanding of the wants, needs, and opinions of end users. Conducting focus groups involves guiding participants to discuss a particular topic of interest. An impartial moderator can ensure the discussion stays on topic by using a semi-structured interview protocol that outlines the topics and questions to direct the conversation. The ideal size of a focus group depends on the topic and the familiarity that participants have with the topic, but Kruger and Casey recommend groups of 5 to 8 participants for non-commercial topics. The second type of user study we used was a think aloud. Think alouds are generally one-on-one sessions in which an investigator asks the participant to complete a series of tasks using the prototype while describing what they are thinking. Insight from the thought process of users can help define user requirements for prototype development. During these sessions, low-fidelity prototypes of the application can be used to inform higher-level design decisions. A low-fidelity prototype can be a sketch or wireframe that presents a bare-bones depiction of the application. The last type of user study we ran was A/B testing. A/B testing can be used to understand the advantages and disadvantages of 2 versions of an application. It is important that the versions are identical and only differ by one feature or aspect. These versions are usually high-fidelity prototypes that are further along in the development process and are close to being a final product. To compare the versions in A/B testing, traffic logs, user flow patterns, or survey responses can be analyzed. There are 2 different procedures used in A/B testing, a within subjects design and a between subjects design. On the left side of the screen, a within subjects design is shown. This design entails that all participants use both versions of the prototype. On the right side of the screen, a between subjects design is shown. This design requires all participants to only use one version. So half of the participants would only use version A, and the other half would only use version B. The A/B testing we ran employed a within-subjects design so that after the participants used both versions, they could be asked additional questions that would directly compare the two versions. Although this design is advantageous in that it allows for a direct comparison, it's important to be aware that there can be order effects, such as users learning or being biased from one condition to the next. It is recommended to minimize order effects by using counterbalancing. The image on the left shows counterbalancing, where participants are split into two groups, so that half of them use version A first and the other half uses version B first. This prevents biases from using a certain version first or last. Next, we will be going into the specifics of our user studies and findings. We had a total of 35 participants for our 3 pilot studies, where each participant was only involved in one of the 3 studies. All studies were conducted at a large public university in the southeastern United States, and participants were recruited from 3 undergraduate computer science courses: CS0, CS2, and Intro to Computer Organization. Students were offered extra credit in their class for participating. On the right, you see our process for the user studies. The Think Aloud sessions and focus groups independently informed a prototype design which was used in the A/B testing. We had 4 participants for the Think Alouds, 14 for the focus groups, and 17 for the A/B testing. Prior to conducting the Think Aloud studies, we had to create the initial low-fidelity prototypes, in our case wireframes. We designed the interface such that users would be presented a snippet of code to trace and then would be asked to complete a line of code to obtain a desired output. All questions presented during the Think Aloud were in multiple choice format for consistency and were on the topic of loops. Loops were chosen since all students have been introduced to the topic already within their current course or a previous course. This is in line with how we believe students would use the app, as a practice tool after having been introduced to the concept in their course. These sample multiple choice questions each had 4 answer choices and allowed the user 3 attempts to answer. After every attempt, the user would receive feedback, and the feedback would become more specific after each subsequent incorrect answer. 4 students from the CS0 course participated in the Think Aloud study. Each participant had a one-on-one session with a researcher where they were shown the wireframe and asked to verbally communicate their thought process while performing tasks. The wireframes were printed on paper and cut out such that the researcher could animate the interactions that the mobile application would have. The interactions were also verbalized to the users. From these sessions, we compiled a list of user suggestions and feedback. Unsurprisingly, participants did not mention anything about the number of attempts, so we concluded that 3 was an appropriate number for the 4-option multiple choice format. Additionally, participants had positive sentiments about the feedback feature that gave hints when they answered incorrectly. The main goal of the focus group study was to understand user preferences for practicing Java and determine how a mobile app could fulfill those needs. We used a semi-structured interview protocol such that we had specific questions to ask, but we had the flexibility to follow up on certain responses or ask questions that came to mind during this session. The focus group study had 14 participants in total, with 13 students from CS0 and 1 from computer organization. We aimed to have 4 focus group sessions with 5 to 6 students each, but due to absences and scheduling conflicts, our 4 groups included 2 5-participant groups, 1 3-participant group, and 1 1-participant interview. Here we show 2 of the questions from our protocol, along with the key takeaways from participants. We asked, what do you imagine a mobile application for practicing Java would be like? Our participants recognized the limitations of a small screen size and suggested that practice questions could involve writing short pieces of code or matching definitions to concepts. This screen size concern is what led us to explore the trade-offs between different question types, specifically multiple choice and fill-in-the-blank questions. Participants also noted that coding questions commonly included long blocks of text, which is not ideal for small screen sizes. They disliked the idea of a scroll view for the entire page and instead suggested using a single page view for the questions. We also asked about their preferences for types of practice questions. They mentioned error identification, definition questions, and looking at snippets of code, also known as tracing code. They also mentioned question formats, including multiple choice, fill in the blank, and drag and drop style questions. In summary, the focus group participants shared our original concerns about mobile screen sizes and suggested potential question formats. Moving forward, the high-fidelity prototype was created using 2 different question formats from those suggestions, multiple choice and fill in the blank, and we conducted A/B testing to see which format users preferred. Based on the feedback from the low-fidelity prototype and the insight from the discussions of wants and needs from the users, we were able to create a high-fidelity prototype. This prototype is a proof of concept and was built on iOS using the development environment Xcode. High-fidelity prototypes of nearly identical applications were created to be compared in A/B testing. Each version had an identical set of questions on the concept of loops. However, the versions had different question formats. One version had multiple choice questions and the other had fill in the blank. This slide and the next few slides show screenshots from the 2 versions of this prototype. On the right side of the screen are the first 2 screenshots, a splash page of the application and a topic selection view. These views are the same in both versions of the application. The user is first given the splash page on the left that shows the logo. To enter the application, the user is prompted to click on the screen. Once clicked, the user is taken to a page to select a topic to be tested on. Theoretically, in a full-fledged application, the user would be able to complete many different topics. But for this report, a partial question set was created for loops. Once the topic is selected, the user is navigated to a question page, which will be shown on the next slide. The left side of the screen shows the fill-in-the-blank version, and the right side shows the multiple choice version. These screenshots show the initial question page a user would see before attempting the question. At the top of the page, there are important navigation buttons and information. Specifically, the topic name and attempt numbers are displayed. To the right of those texts are a back button and a button that navigates to the topic selection page. Below the top area is the question text, code snippet, and the field where a user would input their answer. The fill-in-the-blank version allows the user to type in their answer in the text field, and the multiple choice version allows the user to click on an answer choice. These screenshots show the question page once the user attempts the question and gets it wrong. Directly after the answer is selected, a peach pop-up window shows up telling the user the status of the attempt. In this case, the pop-up window says, "Not quite, please try again." This box disappears after a few seconds. In addition to the pop-up window, a feedback window is displayed. This window gives feedback for the attempt and is placed in the top half of the screen. The question contents and answer inputs are moved down to make room for this window. These screenshots show the screen once the user either answered the question correctly or exhausted the question's attempts. The user would still get a pop-up saying that they answered correctly, but the feedback window would change color to a blue shade and the correct answer will be highlighted in green. In the top right of the screen, the button to the next question also appears. These screenshots also shows what the view looks like when the feedback text is longer. The window expands in size, but users are allowed to scroll within this box to view the entire text. This allows a single page view to be implemented even when some questions are longer than others. A/B testing was used to compare the identical versions of the applications that differ by question type. In total, there were 17 participants, with 3 being from CS0 and 14 from CS2. Just like the Think Aloud user study, all participants had individual sessions with the investigator. As mentioned earlier, we used a within subjects design for the A/B testing. This means that all participants used both applications. The diagram on the screen shows 2 paths that students can take when participating in the A/B testing. In the first path, participants first used the multiple choice version, then were given a survey. After that, the participants were given the fill-in-the-blank version and then given an identical survey. At the end of the session, they were given the comparison survey. 7 participants, or 41% of the participant pool, followed this path. Path 2 is similar, however, the 10 participants used the fill-in-the-blank version first before using the multiple choice version. The participant pool was intended to be split equally, but due to absences and scheduling conflicts, the groups were not exactly equal. We will now discuss the highlighted survey, which was given to the participants after using each version of the prototype. This survey had 3 parts: a system usability scale, also known as SUS, a satisfaction desire to learn section, and an effectiveness section. All sections presented a series of statements that would be scored by the participants using a Likert scale. The first section, SIGCSE, is a validated 10-item survey that is widely used to evaluate the usability of a system or application. A sample statement from this section is, "I found the application unnecessarily complex." Participants scored this section on a 5-point Likert scale from strongly agree to strongly disagree. The satisfaction desire to learn section had 6 statements and was also scored on a 5-point Likert scale. A sample statement from this section is, "This application meets my expectations for a mobile application for practicing Java." And the last section was the effectiveness section. It contained 6 statements and was rated on a 7-point Likert scale. This section evaluated participant perceptions of the application in terms of how effective it would be in helping them practice Java. Sample statement from this section is, "I feel more confident in my mastery of Java concepts because of this system." For the system usability scale, there was a statistically significant difference between the versions, with the multiple choice version having a higher SIGCSE score. A two-tailed paired t-test was performed and there was a p-value of 0.0008. Interesting to note is that SIGCSE scores are out of 100 and a score of 68 or higher is considered acceptable. The fill-in-the-blank version is just below this with a score of 66.18, while the multiple choice version is well above this threshold with a score of 78.97. The effectiveness section was used to understand the user's perceived effectiveness of the app on helping them practice Java. The aggregate scores for this section were out of 42, with the multiple choice version having an average of 30.59 and the fill-in-the-blank version having 29.00. This difference is not statistically significant according to the paired samples t-test calculation. In addition to the surveys given out after a participant used each version of the application, a comparison survey was administered after the entire session. This survey required the participants to directly compare the 2 versions of the application. It had 4 questions and results were analyzed using a 1-sample test of proportions. Here are the 4 questions from the comparative survey. For all statements, the majority of users preferred the multiple choice version over the fill-in-the-blank, with 2 of the statements having statistically significant differences. Specifically, students enjoyed the multiple choice version more and were more comfortable using it. There were no statistically significant differences in terms of the version they would be more likely to use in the future and which version they felt was better for practicing Java. We will now talk about the discussion and conclusion. Overall, we found that following a user-centered approach can give valuable insight into the effective application features on the user experience within a mobile learning tool. A question that this paper highlighted was whether a multiple choice or fill-in-the-blank question format was more appropriate for a mobile tool used in this context. The results from the A/B testing showed that the multiple choice version of the prototype 1. Had significantly higher usability scores, 2. Resulted in greater satisfaction and desire to learn, and 3. Was more enjoyable and comfortable to use. A possible reason for these results is that multiple choice questions require less cognitive load from the user, making them more favorable. The findings from this user study support the idea that multiple choice questions on a mobile platform could be the most appropriate avenue of offering students a repeatable practice opportunity for their CS courses. Lastly, we will discuss future work. As the development of this application is in its early stages, its impact on student learning has not yet been investigated. Future studies could track a user's progress while they use this tool to gain more insight on how student performance is affected. Participants also had relatively short interactions with each prototype before completing the surveys on their experiences. In the future, more long-term studies could be conducted to see how students feel about this tool with repeated use. Future studies are also needed to evaluate the final application's real-world usability and effectiveness. Such studies could help create a more ideal practice opportunity. That concludes our talk. We would like to acknowledge NSF for funding this research and thank the members of the Learn Dialogue group for all their help. Thank you for watching.